Continuing with section 10.2, we are now going to move away from using law of sines and use this new equation that we are going to call law of cosines to finish solving for sides and angles in non-right triangles. What's special about law of cosines is that we are going to use this when we have triangles that are either side, 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 or side, angle, side. Now, remember that side, angle, side. If I have a triangle, I must have an angle in between two sides. If that angle is not in between those two sides, that is not a side, angle, side, and you would be using law of sines instead. So please just make sure you have side, angle, side, and no other combination. Another thing to note is that when solving these triangles, in order to avoid possible side-side angles, so that's where we had that ambiguous case, you're going to use the same law that you start with to complete the entire triangle. So if we start with law of cosines, we're going to always use law of cosines in that problem. If you start with law of sines, always use law of sines. Okay, so looking at example number 1, we have this side angle side triangle. So we know that we can use law of cosines on it. Now, if it helps you to label the vertices, go ahead and do that. And so now from the triangle that I have an angle measure for angle B. So when I go to decide which formula I should be using the one with my angle measure of B. And so that's going to be this equation over here. Now I can use this equation and plug in all of the variables that I have. So my little b is going to be my x. And remember that little a is across from our angle A as well with little c. What I like to do, because my variable that I'm solving for is by itself on the left-hand side, I'm going to take that right-hand side and plug it completely into my calculator. And you should get about 56.92 when you do that. And so if we complete solving, take the square root of that, so x should be approximately 7.5 centimeters. Problem 2 is very similar to problem 1, so go ahead, pause this video, work out problem number 2, and then come back to check your answer that you get for x. Okay, so hopefully you went through and solved for x to be approximately 7.7 centimeters. For problem like number 3, we are given 3 side measurements for a triangle. So let's go ahead and just draw in a non-right triangle. And it tells me side A is 33, B is 7, and C is 37. And so we have to find all of the missing angles within this triangle. First thing that I'm going to do is I'm going to go ahead and look for angle A. And so if I'm looking for angle A, I'm going to need to pick the equation that has angle A in it. So that is going to be this one. And from here, plug in the information that you know. Here we're going to simplify what we can. And solve for cosine A. So if I subtract these two numbers, we should get negative 329 is equal to negative 518 times cosine of A. And if I divide by that negative 518, we get that cosine of A is 329 over 518. And if I take the inverse cosine of that, we should get that angle A is approximately 50.6 degrees. So I'm going to go ahead and label that there. Now let's go ahead and find angle B. So same kind of setup, but different equation because we are using our angle B now. So if I set that up, that should be this. And again, simplifying what we can. If we subtract the 1089 and the 1369 from the right, we should get negative 2,409 is equal to negative 2,442 times the cosine of B. So then cosine of B equals this 2,409 over 2,442. Again, now taking the arc cosine of that number, we get that angle B is approximately 4.9 degrees. And then finally for C, remember we can do 180 minus the two answers we just found. And C should be approximately 120 degrees. Problem 4 tells us that a regular pentagon is inscribed in a circle with a radius of 1 unit. We need to find the perimeter of that pentagon. And it gives us a hint to first find the length of a side using the law of cosines. So remember back to geometry, regular shapes tell us that all of these sides all have the same length. So the hint is telling us to find the length of x, of 1x, and use that to find the perimeter of the entire pentagon. Okay, well, let's draw in the center of our circle and pentagon. And remember that our circle has a radius of 1. So these two sides should have a length of 1. If we're going to use law of cosines, I need to find this central angle here. Well, if I have a pentagon, there should be 5 different triangles that make up that entire circle. Since it's a regular pentagon, they're all going to be the same measure. So we're going to take 360 degrees and divide by 5, and that is going to give us the measure of this one central angle. So this angle is 72 degrees. Now we can use that to go through and solve for x. So we should have that x squared is equal to 1 squared plus 1 squared minus 2 times the cosine of that 72 degrees. And so again, that right-hand side, if I plug it all into my calculator, we end up getting x squared is approximately 1.382. And so 1x should be approximately 1.18 units. But remember, we're finding the perimeter, so I need to take 5 of those. And our perimeter should be about 5.9 units. Last problem that we're going to look at today is problem number 5. And this one is very interesting because it will lead us into types of problems that we are going to continue seeing for the rest of Unit 10. So for this one, it is telling me that town B is 26 miles from town A at a bearing of south 15 degrees west, and town C is 54 miles from town A at a bearing of south 7 degrees east. So let's set up a picture of this first. When we talk about these bearing problems, it might be easiest to think of them on your XY plane, where we're going to have north, east, south, and west as labeled. Since both town B and C are being described from being so far away from town A, let's go ahead and put A at our origin. And so town B is 26 miles away from town A with a bearing of south 15 degrees west. So what that means is we're going to go south and then to the west. So we're going to have some point over here where town B is at, and it's 26 miles away from A, with this measure being 15 degrees from just going south. Then for town C, we are going 54 miles away with a bearing of south and then east. So that's going to be in our fourth quadrant is where town C is going to be. And he is 54 miles away from town A with an angle measure of 7 degrees. So now that we have this picture, the problem is asking us to compute the distance from town B to town C. So we are now looking for this distance here. And I will go ahead and highlight it, and we'll call that X. So now if I redraw this triangle that we've created, we're looking for X, and we know our AB side is 26 and our AC is 54. Angle A, if I take 15 and 7 degrees, that means angle A should be 22 degrees. Now this looks like one of the triangles that we've already solved for the third side using law of cosines. So let's go ahead, set up x squared equals 26 squared plus 54 squared minus 2 times 26 times 54 times that cosine of 22 degrees. X squared should give me about 988.5. And so X should be approximately 31 miles. So towns B and C are about 31 miles away from each other.